Hi my dears, welcome to the new session of our subsidiary mathematics, that is 8.3, the hyperbolic function. Is there any relation between this trigonometric and hyperbolic function? So we have to notice that. Hyperbolic functions are certain combinations of exponential functions which satisfy identities very similar to those for trigonometric functions. We shall see in the next session that inverse hyperbolic functions are important in integration. Next, our aim is to introduce the hyperbolic functions through differential equations. Okay, that is, introduce hyperbolic functions through differential equation. So consider d square x by dt square plus x is equal to 0. That is a differential equation. Its auxiliary equation is given by m square plus 1 equal to 0, m equal to plus or minus I. So the root is given by x of t is equal to c1 cos x plus c2 sin x. Okay, so this cos x and sin x are the solutions of these equations. Okay, and consider this equation d square x by dt square minus x is equal to 0. Its auxiliary equation is given by m square minus 1 equal to 0. So m equal to plus or minus 1. So the solution is given by x is equal to a e raised to t plus b e raised to minus t. b e raised to minus t. Okay. So, and also condition that x equal to 0 when t equal to 0 and dx by dt equal to 1 when t equal to 0. ഇതിൽ substitute ചെയ്യുക. Okay, x equal to t equal to 0 ഇവിടെ substitute ചെയ്ത് കഴിഞ്ഞാൽ t equal to 0 when t equal to 0 ചെയ്യുക. t equal to 0 കൊടുത്തു കഴിഞ്ഞ് കഴിഞ്ഞാൽ x ന് 0 കൊടുക്കണം. 0 equal to a e raised to 0 plus b e raised to 0. അപ്പോൾ a plus b വന്നു. Okay. ഇനി dx by dt 1 കൊടുക്കണം. എപ്പോഴാണ് കൊടുക്കേണ്ടത്? t equal to 0 കൊടുക്കുക. dx by dt means a e raised to t minus b e raised to minus t ആണ്. So 1 implies a minus b. Okay. Next ഇത് രണ്ടും കൂടി ആഡ് ചെയ്യുക. ആഡ് ചെയ്ത് കിട്ടുന്നത് 2a equal to 1 കിട്ടും. So a equal to 1 divided by 2. And b is equal to minus 1 divided by 2. A is equal to 1 divided by 2 and b is equal to minus 1 divided by 2. Right? So this equation is given by x is equal to e raised to t minus e raised to minus t by 2. So this is a relation between the corresponding relation find out cheyananu nammade aim. Nammalku endu kittittunde x is equal to e raised to t minus e raised to minus t by 2. Okay. Similarly, നമ്മൾ ചെയ്യുന്നത് next condition ചെയ്യുക. Next condition is given by when x is equal to 1 when t equal to 0, dx by dt equal to 0 when t equal to 0. Substitute ചെയ്യുക. a plus b is equal to 1 കിട്ടും. a minus b equal to 0 കിട്ടും. So a equal to b equal to 1 by 2 കിട്ടി. So x is given by e raised to t plus e raised to minus t by 2. Okay, so consider this definition, that is hyperbolic sine and cosine. ഈ definition നോക്കുക. Hyperbolic sine function is defined as sine sin h of t. That is hyperbolic sine function. It is pronounced as sinh t. Sinh t is equal to, actually അത് sin h എന്നൊക്കെ വായിക്കുക. That is not a correct way. Okay, sinh t is the correct pronunciation. Sinh t is equal to e raised to t minus e raised to minus t divided by 2. Next is the hyperbolic cosine function is defined as, that is the cos t. That is cos t. Cos t is equal to e raised to t plus e raised to minus t divided by 2. E raised to t plus e raised to minus t divided by 2. That is a hyperbolic cosine function. Next we have to draw the graphs of this hyperbolic sine and hyperbolic cosine. How will you draw this graph? Okay, this is a hyperbolic sine function and this is a hyperbolic cosine. The usual trigonometric functions sine t and cos t are called the circular functions. Right, circular functions, because that is a point, that's a point lies on a circle, on a unit circle. There is a parametric coordinate of a unit circle, that is cos t and sine t. Right. Similarly, there is a relation between the hyperbolic functions and the hyperbola, that is x square minus y square is equal to 1. Consider the parabola x square minus y square is equal to 1. So take any point here. Okay. So this point refers to that is cos t and sin t. So any point on the circle is notated, that is the parameterization is given by cos t sin t. And the parameterization of a point on the hyperbola is denoted by is cos t and sin t. Right? So when you are substituting these in the x square minus y square is equal to 1, you will get here x is equal to what? That is a cos t and y is equal to sin t. So x square minus y square is equal to 1 implies that is a cos square t minus sin square t equal to 1. Okay, so here for the circle, this equation is given by cos square t plus sin square t is equal to 1. So similar relation between these hyperbolic functions are cos square t minus sin square t is equal to 1. And how will you prove this? Cos square t minus sin square t is equal to 1. So substitute here, that is cos square t is equal to e raised to t plus e raised to minus t divided by 2, that is a whole square. So I can write this as 1 by 4 into e raised to 2t plus 2 into e raised to t into e raised to minus t plus e raised to minus 2t. And this is equal to 1 by 4 into e raised to 2t plus 2 in plus e raised to minus 2t. Okay. Similarly, since square t is equal to, that is e raised to t minus e raised to minus t divided by 2 whole square, which is same as 1 by 4 into e raised to 2t minus 2 plus e raised to minus 2t. When we are subtracting this, we will get that's equal to, when we are subtracting these two, that is this e raised to t, 2t, it cancels, and e raised to minus 2t term also get cancelled, and 2 minus minus 2, that is 4 by 4 will come, that's equal to 1. So we can prove that. Similarly, consider the next question, that is show that e raised to x is equal to cos x plus sin x. Cos x plus sin x. How will you prove this? Take cos x, that's equal to e raised to x plus e raised to minus x by 2. Sin x is equal to e raised to x minus e raised to minus x by 2. Then cos x plus sin x is equal to adding these two, that is we will get that's equal to e raised to x. Similarly, we can see that e raised to minus x is equal to cos x minus sin x, and other hyperbolic functions also introduced by using these, that are tan hx is equal to Hyperbolic tan is equal to hyperbolic tan x is equal to hyperbolic tan function is equal to sin x by cos x, and hyperbolic cot is equal to cos x by sin x, and hyperbolic sec x is equal to 1 by cos x, and hyperbolic cosec x is equal to 1 by sin x. And the other identities are sinh of x plus y is equal to sinh x cos y plus cos x sinh y, and cos of x plus y is equal to cos x cos y plus sinh x sin y. Okay, so these are the identities. How do you prove these identities? This is example 2. From example 2, we can see that first of all, sinh x plus y, that's equal to what we have, sinh x is equal to sinh x is equal to e raised to x minus e raised to minus x divided by 2. So, sinh of h of x plus y is equal to what? Replace x by x plus y. So, x plus y minus e raised to minus of x plus y divided by 2. That's equal to e raised to x into e raised to y minus e raised to minus x into e raised to minus y whole divided by 2. We have cos x is equal to what? Cos x is equal to e raised to x plus e raised to minus x divided by 2. And what do you mean by this sinh x plus, what will you get this by adding these two? That's equal to e raised to x minus e raised to minus x plus e raised to x plus e raised to minus x divided by 2. That you will get this will get cancelled each other, and e raised to x plus e raised to x by 2, that's equal to e raised to x. Okay, so that means e raised to x can be replaced by cos x plus sinh x, cos x plus sinh x. Similarly, this e raised to minus x can be replaced by cos x minus sinh x, minus sinh x. Okay, so replace these by e raised to x by cos x plus sinh x, and how will you get these e raised to minus x is equal to cos x minus sinh x? That is, sinh x is this one, then subtract this cos x and sinh x. Okay, so you will get that will be e raised to minus x. So, in place of e raised to x, we have to substitute, that's equal to cos x plus sinh x. In place of e raised to y, cos y plus sinh y minus cos x minus sinh x, then cos y minus sinh y. Okay. ഇതിനെല്ലാം എന്ത് ചെയ്യുക? സിംപ്ലിഫൈ ചെയ്യുക, ക്യാൻസൽ ചെയ്യുക, കട്ട് ചെയ്യാനുള്ളതൊക്കെ കട്ട് ചെയ്യുക. Finally, you will get that is cos x into sin y plus sin x into cos y. So, sin of x plus y is equal to cos x into sin y plus sin x into cos y. Okay. Similarly, you can see that the derivative of the sin x is equal to cos x. How will you prove this? That is d by dx of e raised to x minus e raised to minus x divided by 2. That you will get this as e raised to x minus minus, that is plus e raised to minus x divided by 2. This is actually what? This is our cos x. So this is our cos x. So derivative of the sin x is equal to cos x, and similarly d by dx of cos x is equal to e raised to x plus e raised to minus x divided by 2. That's equal to e raised to x minus e raised to minus x divided by 2. This is equal to sin x. This is equal to sin x. So the derivative of cos x is equal to sin x, and derivative of sin x is equal to cos x. In the case of the trigonometric functions, cos x ന്റെ ഡെറിവേറ്റീവ് മൈനസ് സൈൻ ആണ്, സൈനിന്റെ ഡെറിവേറ്റീവ് പോസിറ്റീവ് ആണ്. ഇവിടെ എല്ലാം പോസിറ്റീവ് ആയിട്ടാണ് നൊട്ടേറ്റ് ചെയ്യുന്നത്. ഓക്കെ. So next is the formula, and also note that these identities, that is sinh of minus x is equal to minus sinh x. How will you find out that? That is sinh of minus x, e raised to minus x. What is sinh x? That is e raised to x minus e raised to minus x divided by 2 is sinh x. Okay, so replace this x by minus x, then you will get e raised to minus x minus e raised to minus of minus x divided by 2. That's equal to e raised to minus x plus e raised to x divided by 2. That's equal to minus of e raised to x minus e raised to minus x divided by 2. That's equal to minus sinh x minus sinh x. Okay, so sinh of minus x is equal to minus sinh x. So that means the hyperbolic sine is an odd function. Similarly, cos x, that is cos of minus x, that's equal to e raised to minus x plus e raised to minus of minus x divided by 2. That's equal to e raised to x plus e raised to minus x divided by 2. That is same as the cos x. Okay, so the hyperbolic cosine is an even function and hyperbolic sine is an odd function, as in the case of, similarly as in the case of the sine and cosine functions. Okay, next we are deriving one more formula here. Sin square x, hyperbolic sine square is equal to cos 2x minus 1 by 2, and this is cos square is equal to cos 2x plus 1 divided by 2. So that the cos of x plus y is equal to what? That's equal to cos x into cos y plus sinh x into sinh y, sinh x into sinh y. This replace this y by x, so you will get, that is cos 2x is equal to, this is cos square x plus sinh square x, cos square x plus sinh square x. So you will get this as, that is cos 2x is equal to cos 2x is equal to cos square x plus sinh square x. We know that cos square x minus sinh square x is equal to 1. So I'm replacing this by cos square is equal to 1 plus sinh square. That's equal to 1 plus sinh square x plus sinh square x. That's equal to 1 plus 2 sinh square x. So I can write it as sinh square x is equal to cos 2x minus 1 by 2. Okay, similarly we can derive this as cos square x is equal to cos 2x plus 1 divided by 2. Okay, next is the derivative of tan hyperbolic tan, that's equal to hyperbolic sec square x. We have the hyperbolic tan is equal to sinh x divided by cos x. By quotient rule, derive this equation. So you will get this as 1 minus hyperbolic tan square x. So from cos square x minus sinh square x is equal to 1, we will get 1 sinh square x by dividing throughout by cos square x. So this is equal to 1 minus tan, the hyperbolic tan square x is equal to hyperbolic sec square x. Hyperbolic sec square x. So we have mainly the hyperbolic functions and their derivatives are Sin x is equal to, we have e raised to x plus e raised to minus x by 2. Derivative of the sin x is equal to cos x. Derivative of the cos x is equal to sin x. Derivative of hyperbolic tan is equal to hyperbolic sec square x. Derivative of the hyperbolic cot is equal to minus hyperbolic cosec square x. And derivative of the hyperbolic sec is equal to minus of hyperbolic sec into hyperbolic tan. And derivative of the hyperbolic cosec is equal to minus hyperbolic cosec into hyperbolic cot x. Okay, so from these definition we can easily find out these derivatives. Okay, next problems we can discuss in the next class. Okay.